Okay, last example, example 4, and in this one I wanted to do one where we rotated about the y. So they say, calculate the surface area generated by rotating this curve about the y from 0 to 12, from x is 0 to 12. So, if we rotate about the y, what changes in our setup? Well, we're going to be integrating or adding up the areas. So it's the 2 pi r, 2 pi r. So if you look at this time, our radius is this way. It's x. So if we pick some circle here, right, of this rotation, it's going to be an x value is how far our radius is going to be. So 2 pi x, okay, and then times the square root of 1 plus dy dx squared dx. So the only thing changes when we rotate about the y is the radius, okay? Now, if we decide to use dy dx or dx dy with respect to x or y, that depends on how we've written our function, as y is a function of x or x is a function of y. That's what affects that. Okay, so since we're doing it with respect to x, our limits are going to be with respect to x. So this is 0 to 12. So we can pull the 2 pi out here. This is from 0 to 12. X square root of 1 plus something squared dx. So let's figure out the derivative here. dy dx is going to be 1/3 times 3/2 times x to the 1/3 minus 1, or 1/2. So it's 1/2 x to the 1/2. And then we're going to square this. So this is going to be 1/4 times x. So this is really x over 4 is what we get right there. Okay, we have to integrate this guy. What I'm going to do here is I'm going to use a u substitution here, okay? I'm going to let u equal to 1 plus x over 4. Okay. And then du is going to equal to 1/4 dx. And if I want to solve for dx, I'll multiply both sides by 4 or divide both sides by 1/4. So 4 du is equal to dx. Okay, what's going to happen here? Rewrite everybody in terms of u. So if we do that, the 2 pi's still there. I will change my limits of integrations in terms of u, but first let's take care of this. I need the square root of 1 plus x to the 4th. I achieved that by writing down u to the 1/2. Okay. I need dx, so I get 4 du. So by writing down du times 4, I got the dx. So you're taking care of this x is not taken care of. So here's what sometimes we have to do. You can solve this equation right here for x in terms of u. So I'm going to do that. I'm going to subtract 1. U minus 1 is x over 4. And then I'm going to multiply by 4, and that's what x is. And I'm going to substitute that in right here. U minus 1 times 4, but I can multiply another 4 over here. So 4 times 4 is 16 times 2. This is going to turn into a 32 pi. That's what I have out here. Then I'm just going to integrate this in terms of u. Let's change the limits. 0 goes in for x. This bottom limit's going to be a 1. 12 goes in for x. 12 divided by 4 is 3. 3 plus 1 is 4. This top limit's going to be a 4. Let's distribute this. This is 32 pi. Integrate from 1 to 4 of u to the 3/2 minus u to the 1/2 du. This is going to be u to the 5/2 divided by 5/2 or times 2/5 minus u to the 3/2 times 2/3 from 1 to 4 times 32 pi. Okay. Okay, I need a little more room. Over here, 32 pi. This is 2/5 times 4. The square root of 4 to the 5th minus 2/3 the square root of 4 cubed minus 2/5, the square root of 1 to the 5th, which is a 1, minus 2/3, the square root of 1 cubed, which is a 1, just like that. All right. All of this. All right. Square root of 2 is 4. No. Square root of 4 is 2. And 2 to the 5th is 32. 32 times 2 is 64 over 5 minus, square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16 over 3 minus 2/5 plus 2/3 times 32 pi. And so what am I going to hear? 62 over 5 minus 14 over 3 times 32 gives me 3,712 over 15 pi, which is the right answer for that one. All right, there we go. That's the end of areas of revolution, surface areas.